Let's look at some more of these limits. So I want you to find each limit. So the first one, the limit as x goes to infinity, 2x plus 5 over 3x squared plus 1. So if I look at this limit, I would get infinity over infinity. Remember, that's our indeterminate form. So here, I'm going to multiply by 1 over x squared on the top and a 1 over x squared on the bottom. And if I distribute that, I get 2 over x plus 5 over x squared. And then it'll be 3 plus 1 over x squared. And if I look at the limit of each piece now, in the top, the limit of 2 over x is 0. The limit of 5 over x squared is also 0. 3. And then the limit of 1 over x squared is 0. So I'm getting 0 over 3, or 0. So there's my first one. Now let's look at the second one. All I'm going to do is change some of my exponent powers here. So let's say now I have 2x squared plus 5 over 3x squared plus 1. Well, here I'll multiply again top and bottom by 1 over x squared. So here I'm getting the limit as x goes to infinity of 2 plus 5 over x squared, 3 plus 1 over x squared. And now if you look at the individual pieces for this limit, you'll get 2 plus 0 over 3 plus 0. I get 2/3. And then the last one we're going to look at, number 3, the limit as x goes to infinity, 2x cubed plus 5 over 3x squared plus 1. So if I again multiply top and bottom by 1 over x squared, we would get the limit as x goes to infinity of 2x plus 5 over x squared over 3 plus 1 over x squared. And in the bottom, I'm getting that the limit here is 0, here is 3, 3 plus 0 is 3, but in the top, I'm getting a limit of 0 here, I'm getting a limit of infinity there. So in the end, this limit is going to be infinity. So if you look at these 3 examples, what did we get? We got, these were always rational functions, polynomials over polynomials. And in the first one, the degree of the denominator was bigger. I got 0. The second one, the degree was the same. It was the ratio of the coefficients there. And then in the top one, or in the last one, the numerator has a bigger degree and the limit was infinity. So we can sum all of this up into the following statement. So limits at either plus or minus infinity of rational functions So in the first example, we learned that if the degree of the numerator is less than the degree of the denominator, the limit of the rational function is 0. So if the degree of the numerator is less than the degree of the denominator, the limit would be 0. In the second example, we learned if they're the same degree, so the degree of the numerator is equal to the degree of the denominator, the limit of the rational function is the ratio of the leading coefficients and in the third one we learned that if the degree of the numerator is greater than the degree of the denominator, the limit of the rational function does not exist. It's either going to be infinity or negative infinity. So if you have a rational function and you're trying to determine the limit at infinity, all you need to do is compare the degree of the numerator and the degree of the denominator and use these rules to help you figure out the limit.